Hey everybody, these are the notes for section 2.3, which is set operations and Venn diagrams. So we're doing 2.2 and 2.3 together in the same module. So hopefully you've already looked at the notes for 2.2. If you haven't, you need to do those first, please. All right, so a Venn diagram is a diagram you've seen before. It's a graphic organizer. In math, what we use them for is to show relationships between sets. So we draw a rectangle. That is used to represent the universal set, the outside of the entire group. And then anything under discussion is divided into subsets of the universal set using circles. For example, there are 4 different kinds of Venn diagrams, really 4 different relationships. The first relationship is disjoint. Basically what that means is there's no relationship. So I have set A, maybe I don't know, let's think about it, and set B, and there is no overlap. So maybe the universal set is pets, and everything in set A is a bird, and everything set B is a cat. Okay, there are no cats that are birds, there are no birds that are cats. There is no crossover here. The second is subsets. So in this case, A is a subset of B, and everything inside of A is also in B. The rule here is that A and B can't be equal, pardon me. So they're not equal, they're not exactly the same. But A is a subset of B. It's also a proper subset of B, okay? Because they are not equal. So if we think about this the same way, the universal set could be pets, B could be cats, and A could be cats that are gray. Okay, all of the cats that are gray are actually inside the set of cats. That's inside the set of pets. Equal sets are when A and B are exactly the same. So all the elements of set A are elements of set B and vice versa. That means you only get one circle because they match, they completely overlap each other. Okay, so if I had, set A was the items in my refrigerator and set B was the items in my refrigerator, I don't know. Whatever it is the 2 sets match exactly. Maybe it's the number of pairs of shoes in my closet and the number of pairs of shoes in my daughter's closet because they overlap. Overlapping sets are much more, this is typically what we see with a Venn diagram. So there's a universal set. I have set A, I have set B, and they have some things in common, but not everything. Okay, and this is when Venn diagrams are most useful. So there are some things they have in common, but not everything. So we could think about it if I had set A, maybe had 1, 2, and 3 in it. And set B had 1, 3, 5, and 7. Okay, there would be some overlap here. They both have a 3 and a 1, but then they also have things that are just theirs. Okay, so the things that overlap go in this shared space. 1 and 3, A just gets 2, and B gets 5 and 7. All right. We use Venn diagrams to talk about relationships and operations with set. The first operation we can talk about is called the complement. This is how you read this, a complement. You either see it like this with the little apostrophe or the bar over it. The complement of a set, of set A, is all of the elements in the universal set that are not in that set. It's like opposite side of the coin, okay? It's its opposite. So if set A is 2, 4, 6, 8, and 10, what's not in A, but is contained in the universe? Well, let's cross out what is in A. Then A complement is 1, need a set bracket, 3, 5, 7, and 9. Okay? That's A complement, the things in the universal set that are not also in A. Pardon me. The intersection is the place where things are in common. We read this as and. okay? This is A and B. So it's the set that has all the elements that both A and B share. So if here's our universal set, here's A, here's B. Well, let's put that in the diagram. What's shared? Let's see, they both have a 3 and they both have a 5. Oh gosh, that should be a 3. That should be a 5. And then A also gets 1 and 9. B gets 1, 2, 4. And let's see, what else? I've used 1 and 2 and 3 and 4 and 5 and 9. So out here in the universal set still floating around are 6, 7, 8, and 10. What's in the overlap, A and B? Well, that's just 3 and 5. We're talking about what they share when we're talking about intersection. If two sets are disjoint, and you imagine their circles, it's like we saw on that first slide. Their circles do not overlap. Their intersection is the null set or the empty set, okay? So A has A, B, and C in it. Set B has D, E, and F. A and B we either write as empty set or as null set. One of the things to note here is that if I have a set and an empty set, that is going to also equal an empty set because they're disjoint. Like if there's things in A and there's nothing in the other one, they can't match. A union is, we think of it as OR. It's the upside down U, okay? It's all of the things in A along with all of the things in set B. So let's draw our picture again. So B has 2, 4, and 6. A has 1, 2, 3, and 4. What's the overlap? The overlap is 2 and 4. So set B has 6. A has 1 and 3. So I've used 1, 2, 3, 4, and 6. So out here in the universal set, I have 5, 7, 8, 9, 10. All right, so or the union is all of the things inside of the circles, all of them, okay? But I only need to write anything once. So I've got 1 and 3. I've got 2 and 4. And I've got 6. It's everything that's contained in those two sets, all right? All right, so there is an activity here. We're not going to stress about it. I'm going to make you a Venn diagram, okay? Here it is, right here. And in here, I'm going to put 1, 2, 3, 4, 5, 7, 9, 10. What did I miss? 6 and 8. All right, so if here's my set, here's A over here on the right, left, and B on the right. How many elements are there in the universal set first? Well, how many things are included in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 things. What's N of A? Remember what N means. It's the number of things in that set. Well, what's included in A? Set A is 1, 2, 3, 4, and 5. Remember, what's included in the overlap is still inside of set A's circle. So how many things is that? 1, 2, 3, 4, 5. All right, N of B. Let's see, B, what's in set B? 4, 5, 7, 9, 10. All right, so there's also 5 things in set B. 1, 2, 3, 4, 5. All right, what is A or union B? Well, I'd have 1, 2, 3, 4, 5, 7, 9, 10. So how many? It asked me for N, right? Number. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 things in there. And then how many things are in the overlap in the center section? Well, 1, 2, it's just 4 and 5. And if you like here, one of the things you might do is pause and make some different sets and try this all again. Make your own sets. Find the number of things in the universal set, find n of A and B, find the union and the intersection. So take a second and try that. Once you do, can you look at the numbers here? I have 5, 5, 8, and 2. And think about a formula that we could use to find union. Well, if we think about it, I could do, the way this really worked is 5 plus 5 minus 2 got me 8, right? There's 5 things in set A, there's 5 things in set B, and the overlapping area got counted twice. So I had to take it away one time. So what we can do to find the union, find the number of elements in a union, is find n of A, add it to n of B, subtract the overlap, n of A and B, and that gets me n of A or B. You can test that out, see if it works. It's a handy formula to have in your pocket, and here it is again if you need it. So the number of elements in the union of two sets is the number of elements in A plus the number of elements in B minus the number of elements in the intersection. All right, let's keep on going. One of the other things we can do is find the set difference. So this is a little strange, okay? This is B minus A is the set of all elements in set B that are not in set A. So what you do is you take out the overlap, okay? If we think about this as a picture, so let's put our sets in here. In set A, I have 1, 2, 3, 4. 2 and 4 are the overlap. 1 and 3, and all I get over here for B is the 6. All right, so B minus A are the things in B that are not included in the overlap. So in this case, all that's not included there is just 6, right? It's this section, this outside. If I was shading, I would shade this part. If I did A minus B, I would go the opposite direction. So I would think about the things that are not shared. So I want the things in set A that are not also in B. So I would think about this part. It would be 1 and 3. Okay. There's some properties of set operations that we need. First, it's commutative. So A and B is the same as B and A. A or B is the same as B or A. The order there doesn't matter. They're also associative, just like we would when we add and subtract. So A and B and C is the same as A and B and C. Whichever one you do first, as long as you're getting all your overlaps, it's all going to work out. Same thing happens for intersection, or sorry, union. You can also distribute, just like we would. So A and B or C is the same as A and B or A and C. Notice how the symbols go here, okay? The other thing is we can describe pictures like this using set notation. So pause for a second and see if you can use some of the properties and the tools we've used to this point to describe these sections. You might just take it one part at a time. Do take a second. All right. So when I look at this picture, I'm going to figure out one section at a time. I just saw this, right? I want to get A without what it shares with B, don't I? So that's subtraction. That's set difference. A minus B. Okay. I also want to get that section of just B alone, which is B minus A. But I want them both. If I say and, I have to take their overlap, and there is no overlap here. So the only way to describe it is a union. I want A minus B or B minus A. All right, there's a couple ways to describe this one, so if yours is different from mine, that's okay. All right, so you can take it one section at a time here. I think about this section here, right, as the intersection of A and C. So A and C. Oh, sorry, I wrote B. Apparently my brain is melting. A and C. Now, let me get a different color. This section here is A, or sorry, not A. Holy moly. Sorry. Is B and C, right? So I have two things right now that together cover everything. So how do I combine them? I combine them with an or. What I don't want here is A and B, right? Because I don't want this section. That's not colored in. Okay, so things to remember. We can use Venn diagrams to solve problems, but before we do that, you have to remember, and is intersection, or is union. When you see not, they're talking about complement. And actually, there was this Venn diagram floating around social media for a little while that makes me laugh, but it's a good use of Venn diagrams. This is a Venn diagram of the overlap between bank robbers, DJs, and preachers. It's silly, but anyways. So set A and set B, if we write them as symbols, is written as A and B, okay? Set A or B is written as A or B. Set A and B and not set C. How do we do that? Well, we know A and B, and a second ago we saw when we're talking about not, we're talking about complement. A and B and not set C, okay? All right, we're gonna make a Venn diagram and solve some stuff. So I have a survey. I'm gonna investigate the high school backgrounds of 110 college freshmen, and this is the information I took. 25 took physics, 48 took math, 8 took bio and math, 45 took biology, 10 took physics and math, 6 took bio and physics, 5 took all three. Phew. Okay. Pause here. Try to make a Venn diagram out of this. Really, it's important that you do this here. Okay. So you've got your picture. We're going to make ours down here. So remember, you always need a universal set. So here's my rectangle. Here's circle 1, circle 2, circle 3. All right, so we're going to call this physics, P, call that biology, B, and call this math down here. All right, so here's the trick to making this work. You cannot start here with 25 took physics. You have to start in the center. If this is something you tried and you got all kinds of crazy numbers for, that's why, okay? You must start in the middle. So there are 5 kids that took all 3 subjects. I'm going to put that right here. Now, here's the trick. Now I'm going to work, I did this one, I'm going to work my way backwards. 8 took biology and math. So that is this section right here. The overlap. But here's the thing, 8 took biology and math. I've already got 5 people in that bucket. So I'm not going to write 8. I'm going to write 3. Because now all together, there's 8. 6 took biology and physics. Okay. Well, here's my Venn diagram spot. That's the overlap between biology and physics. 6 kids took both, but there's already 5 inside of there. So all I need there is 1 more. I took care of that one. And then 10 took physics and math. Same thing. Here's my overlap. I already have 5 kids, physics and math. So all I need is 5 more. All right, same idea applies when we do the next part. So 48 kids took mathematics. This whole circle down here is math. So I already have 5, 10, 13 kids who took math. So this has got to be 48 minus 13. That gets me, ooh, I should use like an actual marker that isn't overlappy weird. So 48 minus 13 gets me 35. Okay, let's do physics. This is the whole physics circle right here. I have 5, 5, 10, 11. 25 kids took physics. So 25 minus 11 gets me 14. And then all I have left is biology. This is the whole bio circle here. So I have 5 and 3 is 8 plus 9. There's already 9 kids in there. 45 kids took bio minus 9 gets me 36. So now we have the right numbers in places. You can use that to answer your questions. But I have something I didn't do yet. There were 110 kids asked. So do I have 110 kids accounted for here? I don't know. We should check. 14, 36, 1, 5, 5, 3, 35. All right, 14 and 36 is 50, 51. 10 more is 61. 3 more is 64. So 64 and 35 gets me 9, 99. No, so there are some kids that didn't take any of those things. So out here I have 110 minus 99, that's 11. So there are 11 kids that didn't take any of those 3 subjects. So how many kids took bio, but neither physics or math? How many kids only took bio? Well, take a look at the picture. They didn't take physics or math, they only took bio. How many are in there? 36. How many took physics, bio, or math all together? Doesn't have to say both or 2 or 3, just any of those 3 subjects. Well, it's going to get us 99 because it's everybody who took anything, right? Except for the kids that didn't take anything. And then how many didn't take any of the 3 subjects? We figured that out already, 11. So you will do more of these, but try it again if it took you a minute to figure out, go through this, okay? This is really important. All right, and then the last thing here is Cartesian products. The set of all ordered pairs in the form AB, where A is an element of set A and B is an element of set B, is a Cartesian product. So it looks like a multiplication symbol, but here, what it means is, the other thing it's called a cross product, is it's basically like a pairing. So we take each thing from A and pair it to B. So 1, 2, 1, 4, 1, 6. And then we do the next one. So from A, I'm going to take 2 and put it with the 2 in B. 2, 4, 2, 6. I'm going to take the 3 from A and pair it with the 2 from B. 3, 4, 3, 6. And then the last element in A is 4. I'm going to pair it with all the elements from B. 4, 4, 4, 6. This list, these 12 items, are the Cartesian product, the cross product for this. All right, that is the end of notes for this section. From here, if there's anything you need help with, you should ask. You should particularly practice Venn diagrams. You'll get another chance too. Move on from here to the MyMathLab homework. Work on the written assignment and the discussion. We'll see you in there in the discussion board. Thanks.